Hello everyone, welcome to Crazy About Maths. Now let's see the properties of rational number. The first property is closure property. Okay, now let's see under whole numbers. If we take addition, two plus 3 is equal to 5, 0 plus 4 is equal to 4, anything 10 plus 20 is equal to 30, any digits, any elements from the set of whole numbers, if taken and added, we get the element which is present in the whole number. So we can say the whole numbers are closed under addition. Now let's see subtraction. If we take 3 minus 2, we'll get 1 which is present in the set of whole number. Okay, now let's see a smaller element in the first place, that is, let's take 2 and minus 4, so we'll get it as minus 2. 2 minus 4 is minus 2, and minus 2 is not present in the set of whole number. Because of this, we can say whole numbers are not closed under subtraction. Now if we take multiplication, if we take any set of element, that is 3 into 2 will be 6, or 10 into 11 will be 110, or 5 into 4 will be 20. Every element is present in the set of whole numbers, so we can conclude that whole number is closed under multiplication. Now let's see for division. We can consider any element from the set of whole numbers for checking any of the properties. Okay, now if we consider 3, okay, let's take it as 6 divided by 3, we'll get it as 2. Then if we take 4 divided by 3, which is equal to 1.333 and so on. We represent this symbol for recurring digits, but this is not present in the set of whole numbers. This is actually a rational number. This became a rational number, so we can conclude that whole numbers are not closed under division. We can take anything 5 by 2, which comes to 2.5, which is not present in the set of whole numbers. So we can conclude that whole numbers are not closed under division. Now let's see for integers. Let's see for integers. We know the set of integers is from minus infinity to minus 2, minus 1, 0, 1, 2, so on up to. So now if we take addition, we can consider any set, any element from the set, any elements from the set. So I will take minus 3 and let me take plus, let me take 2, which will be equal to minus 1, and which is present in the set of integers. If we take 2 plus of minus 5, which will be equal to minus 3, which is present in the set of integer. So we can conclude that integers are closed under addition. Now if we take subtraction, we can take any element from the set. So let me consider minus 5 minus of 2, which will be equal to minus 7, and let me take 5 minus 4, which is equal to 1. Anything, any elements can be subtracted and we get this elements which are present in the set of the integer. So we can also conclude that integers are closed under subtraction. Now let's see for multiplication. Okay, we can take an element minus 3 into minus 1, which will be equal to 3. You guys can see that minus of minus will get a positive number. If we take a negative number into a positive number, we'll get a negative number. Rule is plus into plus will give us plus, minus into minus will give us plus, minus into plus will give us minus, plus into minus will give us minus. You guys must need to remember this rule. This is the basics. You guys must need to remember this rule. Okay, yeah, as we saw, if we multiply any element present in the integer set, we'll get the element which is present in the integer set. So we can say that integer are closed under multiplication, are closed under multiplication. Now if we take division, yeah, we can consider any element like if we take at starting minus 4 by 2, we'll get it as minus 2, which is present in the set of whole number. Okay, now let's take minus 3 by 2, we are gonna get minus 1.5. This is actually a rational number. This became a rational number. This is a integer, this is an integer, when we divide these two elements from the integer set, we get a rational number, and which the resultant is not present in the set of the integer. So we can conclude that integers are not closed under division. Now let's take the third one, rational numbers. Okay, we know that it must be of the form p by q, and q must not be equal to 0. This is the condition. Okay, now let's take for addition. Okay, let's take 1 by 2 is a rational number, and 3 by 2 is also a rational number, which will get 4 by 2 is a rational number. Okay, let's take minus 4 by 3 and 2 by 3 will get minus 2 by 3, which is a rational number. So we can conclude that rational numbers are closed under addition. Okay, now let's take for subtraction. Okay, let's take 3 by 5 minus 1 by 5, which will get us 2 by 5, which is a rational number. We can take minus 3 by 5, maybe minus 3 by 6, and minus 5 by 6, which will be equal to minus 8 by 6, which is a rational number. So we can conclude that rational numbers are closed under subtraction. Now let's take for multiplication. Okay, we'll consider 3 by 5 into 4 by 6. We can further simplify, like 3 ones are 3 twos are, and 2 ones are 2 twos are, which can be finally written as 2 by 5, which is a rational number. Now we can take 4 by 7 into 2 by 3, which will be equal to 8 by 21, which is a rational number. We can take any number, minus 3 by 7 into 4 by 2, which will be equal to minus 12 by 14, which is a rational number. So we can conclude that rational numbers are closed under multiplication. Now if we take for division, we can take as I had mentioned earlier, 3 is a rational number which can be written as 3 by 1, and we can take 3 by 1 divided by 4 by 2. So we can write it as 3 by 1 divided by 4 by 2. We can see that this can be simplified. 2 ones are 2 twos are, and it can be written as 3 divided by 2, which is a rational number. But we know that this is the most important condition for a number to be a rational number. Okay, as I had mentioned earlier, we can write any integer or whole number or natural number in the form of rational number. For example, as I showed, 3 can be written as 3 by 1, 2 can be written as 2 by 1, minus 5 can be written as 5 by 1. Everything can be represented as in a form of a rational number. So if I'll take that 5 by 1 divided by 0 by 1, this is also a rational number, but the resultant 5 divided by 1 divided by 0 divided by 1 will be equal to 5 divided by 0, which is not a rational number, because q is equal to 0, so it is not a rational number. So we can say that rational numbers are not closed under division. You guys can think that why we didn't use this in multiplication. We can use, you can see 5 by 1 into 0 by 1, because this is a rational number, this is a rational number. We'll get it as 0 by 1, which is a rational number. So the rational number was closed. Rational number was closed for multiplication, but it is not closed for division. Okay, thank you for watching Crazy About Maths.